Okay, great. Well, welcome everybody. It's certainly my pleasure to be able to present this topic today. As Lori mentioned, we are recording this, so I wanted to mention that we're scheduled for 30 minutes, but it's likely we're going to go a little bit long. So if anybody needs to drop off, we certainly understand that, and so don't worry that you're going to miss anything. It'll probably mostly be questions and answers really at that point. So anyway, with that, we'll get into it here. So kind of the topics that we're going to try to cover here today is just a little bit of an overview on what is heat stress, how does that physiologically impact the cow, and also what is the economic impact of heat stress from a producer perspective. I also want to spend a fair amount of time introducing and really talking about the new product that we've developed here at Ralco, and discuss phytonutrients and how they can impact physiological processes, as that will be related to the product in question. We'll review those modes of action, try to validate those, and then also give a little bit of a research overview, just a few things on some actual performance of the product in the field. So I want to start off here and really reinforce to everyone that there really are no magic bullets when it comes to managing heat stress or really any kind of stress in an animal. And so I think good tips, just for good animal husbandry practices are certainly at play. I'm not going to spend a lot of time on these, but just wanted to really bring it to everybody's attention that, products in general are not a replacement for some good management. So again, a holistic approach is always best. So try to do, as much as you can from a management perspective to help your animals. So as we, really talk about heat stress and what it is, obviously as the temperatures get to a certain level, and it can kind of range in ruminants here. I've listed from 65 to 80 relative heat index. Cows are going to start to experience physiological, metabolic, and even enteric issues trying to really cope with and deal with the heat load that they're experiencing. And part of the reason why this is a variable number is just really due to body condition score perhaps of the animal, level of production, level of feed intake. Because in a ruminant animal, we have a lot of production or a lot of heat produced just simply due to fermentation in the rumen. And so as a response to that, one of the first things an animal will try to accomplish or try to do to help alleviate some of the heat stress is just to start to reduce intake to offset some of that heat. And so something to be aware of as this is going to be a major challenge for us in terms of trying to make up some of the production that we're going to lose with that drop off. So won't belabor this point too much, but the ruminant animal is not a real efficient sweater. So their main source of dissipating heat is going to be through exchanging heat with the air, mainly through the lungs and panting and breathing. And so this just is a kind of a reminder that as humidity levels will increase, the efficiency with which they can transfer that heat is going to go down. Okay, and so obviously as the humidity levels will increase, the temperature in which these animals can start to really experience heat stress to the point of being even emergent doesn't have to reach a real high ambient or dry bulb temperature. Okay, so just something to kind of keep aware of. So just kind of on the previous slide to reiterate that production certainly influences heat production. So just a little fact here that I found that I thought was interesting was a cow that produces 70 pounds of milk produces 48% more heat than a dry cow, right? And so that percentage can go up from there. But obviously, as these animals are high producing and as they're consuming a lot of feed, there's just a lot of heat of production as well as heat of fermentation. That's going to compound the problem. So as we think about, what's the impact from really what are we going to experience, maybe from an economic perspective, obviously the first thing is going to be performance reductions, whether that be a average daily gain maybe in a feedlot steer or certainly milk production in a dairy cow. The components can change from a dairy perspective, creating some additional economic drain. We can get some health issues, somatic cell count increases, etc., and then reproduction. And it's probably one of these, the reproduction side is probably a little bit more of a silent thing. We probably don't necessarily always recognize that, but it can be very significant both in cows and particularly in bulls. Can be certainly impacted pretty dramatically by heat stress. Ultimately, and we certainly hope to avoid this, and that's why I reiterate that some management probably does need to be in play here, because ultimately animals can die as temperatures do reach excessive levels. So one of the interesting things that we'll spend quite a bit of time talking about is most of these things up here are going to be rooted in some physiological changes in the animal, mainly in terms of some metabolism changes and particularly gut health. And so we'll spend some time on that. I do want to indicate the economic significance of this. From a beef industry perspective, we're at about $370 million. It's estimated to cost the beef industry, and that goes up to $900 million in the dairy industry. So just for some perspective, that's just under $100 per cow, right? So if we're talking about some mitigation techniques that maybe we can spend a few dollars, there's certainly a lot of money on the table that can be redeemed. So this here is not going to be too related to my presentation today, but I find it interesting, and I think it does really speak a little bit to some of the management things that we should consider. So as these animals, get under heat stress, a couple things are going to happen, right? They're going to start to breathe hard. They're going to pant. Intake's going to be reduced. They're not going to be ruminating as efficiently. They're going to be drooling. And all of those things tend to lead to excess CO2 being blown off in the breath, as well as losing a lot of the buffer or the saliva, which is a major buffer for the rumen, is going to be lost to the environment versus being returned to the rumen. So one of the first things we can see is some real rumen challenges, and it's just something to be aware of, because I think things like some good management practices like keeping fiber in the diet, keeping maybe some bicarbonate or buffers in the diet are probably very good, pretty good management practices to keep in place. Okay, so to get into kind of the heat of the matter here, just would like to recognize, Lance Baumgart and some of the guys, others at Iowa State, have done a lot of really good work in this space of heat stress and how it affects the animal. So this was a trial where they compared some heat-stressed animals and measured what their intake was, right? And so that's represented here. And then pair-fed another group of cows that were not heat-stressed. So whatever the reduction in feed intake was here was fed to this group of animals. And essentially what that allowed them to measure then was how much of the loss in production, in this case milk yield, how much was due to just intake and how much was due to factors other than just intake. And so representing here in this green is variables, factors that have nothing to do with feed intake that contributed to additional milk production losses. So it's easy to see here that roughly 35 to 50% is going to be due to intake, and an equal 50% or more can be due to these other variables. So I would say that if an animal's heat stressed, it's going to be hard to get all the intake back. There's certainly some things we can do to help, but this green bar here really represents an area where we can have some intervention strategies to try to achieve some of that performance back. Okay, so if we think about really what's going on here, we'll get an animal that's experiencing some level of heat stress. Maybe additionally he's getting some social stress, get a little irritable when they get hot. And so one of the first things the animal is going to really try to accomplish at this point is to try to cool itself. And the principal way that they're going to do that is through vasodilation, right? So they're going to push blood to the surface of the body to try to dissipate some of that heat. And that's going to create a scenario in the gut where we're going to have some oxidative stress, we're going to have less blood flow, and it's going to create a scenario where we have leaky gut. And we'll talk more about that here just in a minute or so, but it's kind of this vicious cycle of, inflammation is going to occur due to some bacteria and other things crossing the gut. And so all of these things here, we're going to have leaky gut, which leads to the immune system being activated. There's an energetic cost, right, that's associated with these type of things. So this is energy that's being utilized at the animal level for something other than producing performance or milk in this case. We're going to have inflammation. There'll also be some other metabolic changes that are going to cause some issues with particularly milk production. So if we think about, leaky gut here, I mean, this is probably most people understand this, but this is a really nice picture showing that, an animal that this is really what a gut should look like. It's nice and healthy, villi very tall. There's no porosity here. There's no holes in this gut where the bacteria can leak across, whereas we can see here in an animal that has some damaged gut due to this, lots of opportunity here. These, villi have been shortened. They're not as healthy. We have gaps here that the bacteria and undigested feed, toxins, whatever might be in the diet can actually leak across the small intestine and get into the bloodstream. And once there, we can have immune system challenges. So lipopolysaccharide is really what's been more recently, I guess, shown to contribute to a lot of the challenges here. So the LPS is essentially just a major component of the outer membrane of gram-negative bacteria. And as those gram-negative bacteria and this LPS gets into the small intestine, that's creating these immune challenges, upregulation of the immune system, inflammation. All those things are going to create issues with the animal. I found it very fascinating that you can see 500% increases in LPS within just 12 hours of a heat stress onset. So these things can happen really pretty fast. And and I think if we stop and think about it, it makes sense that if we start changing blood flow and things to the gut, that's a very metabolically active organ, right? It's going to need a certain amount of nourishment and care taken of it. And so if we start changing things there, we can have some really dramatic impacts in a very short amount of time. Just as a little bit of a side note here, I thought this was just some interesting things that I found in kind of researching this area, that LPS is associated with all mammals, including humans, whom it was associated with gluten intolerances and other conditions like stroke, Crohn's disease, and even alcoholism. So just kind of interesting how LPS has a pretty dramatic effect across a variety of different animals, species. So just to kind of maybe summarize this, we talked a little bit about leaky gut here, right? So we just have a diagram showing the bacteria or pathogens or whatever, feed particles, and this tight junction here being kind of broken down. That's going to be eroded, and it's going to allow these bacteria access across the lumen of the small intestine and to go into the bloodstream. Right? So all this is really happening because of this, blood flow being pushed away from the skin or being pushed to the skin away from the gut, which is going to create oxidative challenges at the gut. It's going to create, lack of immunity and blood flow, just general nourishment of the gut, which is going to create the scenario where we get leaky gut. And so this just kind of sits here and kind of keeps spinning around as we deal with heat stress. Ultimately, the immune system is going to be activated, going to get some nutrient redistribution. One of the other things that wasn't real clear to me why it happens, other than it does seem to happen, is that insulin levels do tend to increase in an animal that is heat stressed. Okay, and so that's going to have implications on fat storage from adipose. Glucose is going to be pushed into that. We're going to get skeletal muscle breakdown, and more importantly, I think, and particularly as it relates to milk production, is we're going to get glucose shifted away from milk production, right? It's going to be pushed into these other tissues, and we'll come back and talk about that in a little while. But ultimately, all of this energetic cost and immune system activation and the energy associated with that, as well as lowering glucose, is going to result in some level of lost performance. So what can we do about it? So we're going to really talk here now about how phytonutrients can maybe impact some of these physiological processes. And a lot of this happens through, and this might be new information for a lot of people, it certainly was for me until we kind of started studying on this, but TRP channels are really an interesting thing in that they're these channel proteins that serve as sensors, basically, for the animal. So they allow the animal and individual cells to really communicate or detect changes in the environment, and then communicate, ways to alter that, right? So it's the way the animal maintains homeostasis. And so these are going to be expressed on nervous tissue, the intestines, pancreas, immune cells, really quite a diverse group of areas where you can find these TRP channels. The more interesting thing is really the fact that phytonutrients have been shown to actually bind to these TRP channels and activate some sort of physiological response. So we'll talk about that a little bit more, but just as a bottom line, to kind of keep it simple here, TRP channels are the body's way of sensing and regulating physiological processes in an effort to maintain homeostasis. Now that might be temperature, but it could be any number of things. It could be blood glucose level, it could be any number of things, but it's essentially in an attempt to maintain homeostasis. So just as maybe an example to maybe make this a little bit more real, we can talk about some different types of TRP channels. They're going to be located, as an example, here on the skin. Some are going to be found on the gut, wherever. And something's going to stimulate those. Could be a phytonutrient, could be a change in the environment, and that's going to make some sort of a signal. So in this case of a heat example, it's going to signal the brain. The brain's going to say, hey, we're hot. We've got to do some things to try to cool ourselves off. So it's going to signal via nervous tissue to do things like maybe dilate blood vessels on the skin to help dissipate that heat, as well as activate sweat glands for cooling. And ultimately, there's going to be some sort of energy expenditure created during all this process. So back on the phytonutrient side of this a little bit. So phytonutrients can really act in a couple of different ways, right? And so one is in the context that we might normally think about, things like essential oils being antimicrobial or antiviral, et cetera. That's going to be pretty much a direct effect, right? That means that there's some physical contact that has to happen. It's going to be a very direct response, right? Whereas when we think about the systemic or maybe indirect effects acting through, say, TRP channels, now we're talking about things like maybe being anti-inflammatory or modulating body temperature or changing blood flow or other metabolic changes. So those are going to really be more of an indirect or systemic type effect that's going to be activated through these TRP channels. So just as an example, here's several different TRP channels that have been identified and just showing different phytonutrients that have been shown to have activation of these different ones, right? So if you kind of understand what TRP channels are doing and what you're trying to accomplish, can help you kind of pick out different types of phytonutrients that might be able to help modulate that response that you're looking for. Okay, so Comfort is really a product that I want to spend a little bit of time talking about here today. It's a new approach to the challenges of heat stress, kind of taking into account some of this phytonutrient, TRP channel, and other benefits of essential oils and phytonutrients. So Comfort is a blend. It's an essential oil blend of oregano, thyme, and cinnamaldehyde are going to be the three primary constituents. Those are going to be microfused with a prebiotic fiber, and we'll spend a little time talking about what that is and why that's important. And then ultimately we're going to combine that with capsicum. The goal here was to help overcome some of the physiological responses associated with heat stress, hopefully improve feed intake, and ultimately minimize production losses. So this does come in a 40-pound bag. This is a foil bag, so that's important as the essential oils can be fairly volatile. And so we want to make sure that we keep them in the product and not being lost to the environment. The feeding rate is recommended at a half a gram per 100 pounds of body weight up to about 5 grams really maximum. So that's a little bit of the details on the product. If we think about really what it was designed to do and how we really approach that process. So we've talked about already here today, some of the things associated with heat stress are going to be gut health, right? So we wanted to think about how can we really improve gut health? What is the cause of some of that damage? Is it bacterial? Is it pathogen related? Is it oxidative stress? What is it? So we've identified we're going to have some antioxidant stress or some oxidative stress. So we wanted to really focus on some antioxidant type properties as well as, maybe regulate insulin. Is there something we can help with there? Anything we can do to help the animal better regulate temperature and ultimately, if we can, improve feed intake. So these were kind of the things that we were really trying to think about in development of this product. So the approach that we take really at Ralco is just really understanding different attributes and properties of these essential oils or really any other phytonutrient. Not all phytonutrients have to be essential oils, right? But so if we think about, a lot of these products, a lot of these phytonutrients are going to have a lot of overlap, but each one does have some areas where it will excel. And so the strategy was to really just try to line up the most beneficial attributes of each of those oils or phytonutrients as it related to these challenges. And so we wanted to focus on things like homeostasis, antimicrobial from a gut health perspective, obviously antioxidant, and then these, and we're going to get some of these other benefits, right? But these weren't the ones that were primarily focused on. They just kind of come along for the ride when we were trying to really identify this. So if our strategy was to create competitive exclusion, we would take a different strategy in terms of how we would either put which products we would put together or maybe the relative ratios to one another. So this was kind of the concept that we use that we've termed here at Ralco for our formulation on essential oils to develop the right product for the right problem. Okay, so just go ahead and apologize up front. I know this is a pretty busy slide, but we'll just kind of walk through it one piece at a time here and really show you how all of these different components are going to really interact in the animal to accomplish the desired purpose. So So if we really start here with ration stability, okay, so that's one thing. A lot of these dairy diets and really most, even feed yard diets today are pretty wet, right? And if we're having heat challenge issues, that feed's going to start to want to mold. It's going to, we have yeast production, and it's just going to start to rot essentially in the bunk. Get pretty slimy. It's not going to be very palatable. It's going to heat up. All of those things are not going to help palatability or consumption. So something that's really focused more on being antifungal, mold, yeast, those kind of things, and really oregano and thyme are going to be doing a lot of the really heavy lifting in that space. Similarly, as we just want to improve overall gut health, we want to talk about reduction of pathogens, hopefully eliminate some of those gram-negative bacteria as well to limit any of those LPS challenges. And so again, really all three of these essential oils are going to really contribute well to gut health and its antioxidant capabilities. We'll talk a little bit more about that. So all this is to maintain those tight junctions and minimize the amount of leaky gut that we get in the first place. Okay, so these are all pretty direct responses, okay? If we kind of think about indirect responses, then we're going to be activating through our TRP channels, right? And so if we think about oregano and thyme, those two in particular are going to be associated with the channels related to cooling, right? The animal's ability to vasodilate, sweat, do those kind of things are going to be activated through these TRP channels associated with oregano and thyme. Now, capsicum, on the other hand, is going to be very beneficial in activating TRP channels associated with the pancreas and regulating this insulin and glucose, okay? Now, the other thing that happens, and one of the other benefits of capsicum here, is that we've talked about the natural process is for the animal to vasodilate itself. It's going to pull blood flow away from the gut. So one of the benefits of capsicum, especially as they consume it, right, is the feed is there, it's going to actually stimulate some blood flow back to the gut, helping kind of keep that gut in check, keep it healthy, keep the immune system working there the way that we would want it to. And then additionally with capsicum, one of the other benefits that has been seen and documented is increased water intake and smaller, more frequent meals. This really goes directly to reducing that heat of fermentation and keeping the animals on a more steady plane. And so really all of these components here are going to act in multiple different ways to hopefully deliver us the desired effect. So just as a summary here, I kind of wanted to just validate some of these points a little bit. So we'll first start by summarizing those. So again, we wanted to get this ration stability to help support feed intake. So that's going to be really an antifungal type property. And again, the active components there are going to be oregano and thyme. As it relates to really gut health, leaky gut reduction, things of that nature, reduction of pathogens and gram-negative bacteria perhaps, is really going to be all three of our essential oils here, oregano, thyme, and cinnamaldehyde, enhanced by our microfusion process. We'll talk more about that. But that's going to allow consistent contact with the pathogens, right? So it's like I said, this is a contact sport, so those things have to physically touch in order for that to happen. So microfusion really enables us to get those oils in contact, in close proximity to the pathogens. And then Actified, it's going to be a prebiotic fiber, so it's going to feed the beneficial bacteria, and we'll get some competitive exclusion as a benefit of that as well. So then the antioxidant properties are going to be really all three of these oils are going to combine nicely together to create this nice antioxidant package that we're going to deliver. And then if we think about regulating the body temperature, as we've discussed, that's pretty much pretty specific to oregano and thyme. And then capsicum's benefits are going to be stimulating blood flow back to the gut, maintaining more normal insulin levels and smaller, more frequent meals. Okay, so just want to validate some of these benefits and some of the work that we've done or that I could pull out of the literature. And so this was just a trial really showing some field trials that we did at Ralco over the years, documenting, this would be particularly with more of an oregano and thyme based product, significantly reducing the mold and the yeast counts compared to a negative control. So that's going to result in keeping feed fresher, more consistent intake, more energy for production, i.e. the feed, in terms of just being more energy in the feed, and better intakes, as well as reducing feed losses, which can be pretty significant if you have to throw away half the feed that you feed every day because it's molded in the bunks. So this slide here really speaks to the antimicrobial properties, and this one was of oregano in particular, because it's probably one of the more potent antimicrobial oils that we would deal with. So this yellow bars here just represent the zone of inhibition. So how far out was it able to inhibit these known bacteria pathogens, right? And so you can see compared to, excuse me, any number of popular antibiotics, that the oregano essential oil is very effective at inhibiting these bacteria. So if we think about other essential oils that we might want to compare to, so we would have things like oregano, thyme, cinnamon, lavender, bay, lemongrass, etc., peppermint, you name it, and their active component. Compared to other phytonutrients or essential oils, again, carvacrol and thiamol, active components in oregano and thyme, are going to be at the top of the list in terms of their ability to inhibit bacteria in this case. So this is minimum inhibitory concentration, right? So how much do we need to have to really create an effect? Cinnamon's right there at the top. And so these three were selected kind of based upon that principle. Now, one good example, and it kind of reinforces this idea of kind of this NEXUS formulation, is that all these products will have some benefit, right? And there may be some specificity. And so while cinnamon maybe wasn't the most overall inhibitory, if we want to look at Clostridium perfringens in particular, it was one of the most inhibitory. So again, kind of really understanding what is the challenge we're dealing with, and then really putting the right products together to address that. So I want to talk about microfusion a little bit, and that's a proprietary process that we use here at Ralco to make our oils essentially better emulsified, right? They're going to be smaller in droplet size. So you kind of see a difference here visually of kind of an oil. You're going to get some separation, or this process is going to make it very water soluble, very stable. And really the bigger benefit is this reduction in particle size or individual droplet size. And so we're going to get 100 or 20 times greater surface area, which is going to allow more points of contact for the bacteria. So if we think about that, and how that might work, right? So when we emulsify an oil droplet, we're going to reduce that down to about the size of the bacteria itself, right? The pathogen that it's interacting with. So it's going to be able to there's going to be more of them, number one, so we're going to be able to touch more of them, and we're going to be similar in size, and then we've also decreased the surface tension, right? So not only do we have more of them, this reduction in surface tension allows that droplet to get closer to the bacteria. And as I mentioned, this is a very direct effect. It has to come in pretty close contact for it to perform its function of killing this particular bacteria. So we're really getting both benefits to the microfusion process, right? So one is more particles can touch more bugs, and then secondly, all of those particles can get closer. Okay, so just to, again, validate that point a little bit, we can look at a couple different oil blends that were not microfused, and then the one in the green here is actually going through a microfusion process. So in all cases, with the exception of one, with staph, but for E. coli, Bacillus, Salmonella, Streptococcus, we were able to pretty significantly reduce the minimum inhibitory concentration of these oils just simply by going through this microfusion process. So just to touch on antioxidants for a second here, again, I think antioxidants as a general rule are probably undervalued in the industry, or maybe I should say it another way, maybe oxidative stress is not valued enough, right? I think at the end of the day, I believe that oxidative stress and these free radicals are a major contributor to a lot of the disease and the challenges that we deal with in livestock, right? I mean, almost everything that the animal does creates oxidative stress, whether it's mounting immune response or whether it's the physical active production, creates oxidative stress. And so that has to be dealt with at some level, or it's going to create issues and additional challenges for the animal. And so one of the really interesting things about comfort, or really in our case these essential oils in here, is the tremendous amount of antioxidant capacity that they have, right? So this is just comparing it to natural vitamin E, just a very common, very well-known antioxidant, right? And so we're getting 40 times greater antioxidant capacity, but also, and maybe more importantly, I don't know if it's more or not, but it's certainly importantly, is that we're also touching all of the boxes here, right? So we're going to have application or reduction in oxidative capacity across all 5 of the reactive oxygen species. So it's not just about the total level, but it's also about being able to have activity across all the spectrum of free radicals. Okay, so this isn't a real pretty slide, but I just wanted to kind of validate a little bit this point on TRP channels. So just as a reminder, we talked earlier that there are these large and diverse family of channel proteins that serve as sensors, allowing the cells to detect and changes to the environment. Okay, there's been over 50 of them identified into kind of like 7 subfamilies. And so just pulling this out of the literature again to validate my point, you know, that capsicum through this innervation and activation of TRPV1 is going to have some immune system modulation as well as improving the mucosal blood flow. Again, that's going to be very important for those animals that are being heat stressed and vasodilated, pushing blood away. You know, getting some blood flow back to that small intestine will be pretty important. Additionally, with capsicum through this insulin scenario, just again documenting that capsicum decreases serum insulin without affecting glucose concentration during a glucose tolerance test. Now, this is kind of interesting too in that you know, the mammary gland does not require insulin in order to utilize glucose, right? And so there's no way to make lactose, the milk, the sugar in milk, there's no way to make lactose without glucose, right? So it's a very glucose dependent tissue that, you know, needs glucose. Now, by keeping the insulin levels down, right, then we're able to keep more glucose in the circulating blood flow, and the mammary gland does not actually need that insulin in order to take up glucose, whereas, you know, muscle tissue or fat tissue is going to require. So in a sense, it's sparing glucose that can be utilized through this non-insulin dependent pathway. So again, one of the key kind of benefits, I think, from a milk production perspective. And then lastly, through this TRPV channel 3, it's going to operate in the physiological temperature range of 89.6 to 102 degrees Fahrenheit. So again, that's going to be in our heat stress zone, obviously. And TRPV3 is strongly activated and synthesized by the monoterpenes, carvacrol, and thymol, components of oregano and thyme. So again, just to provide a little bit of documentation of the efficacy and of some of these products from a particularly heat stress perspective. Okay, just to validate that point, this was we did this a couple times. I just kind of summarized one trial here, but when we would feed comfort compared to a negative control, we would see a pretty consistent reduction in the surface body temperature of the animals. So if we look at specifically some research with the product, this was a trial from Florida, actually conducted from May to June. So you might imagine in Florida, going from May to June, the temperatures are going to increase pretty linearly. And when comfort was fed, we were able to maintain, if not even slightly increase, feed intake, right? And also, we don't have quite the variation around that mean, whereas the animals that did not receive the product are going to have reductions in intake over time and a lot bigger swings in terms of that feed intake on a daily basis. So to summarize that, and again, this was some of the mold data we talked about earlier as well, but it's kind of from these same states. In the presence of the product, we're seeing improvements in both dry matter intake and milk production from, you know, about 1 to 2 pounds in intake and from about 1.5 to 5 pounds in milk production. And then the last trial that we had was actually just completed here this last summer. This was actually a university trial, and where we fed comfort to some feedlot cattle. It was certainly hot in West Texas at the time of this trial, and this was just kind of a summary during that really heat stress time of the cattle. These were fat cattle too. They were, you know, 1,400 pounds and experiencing 100-degree heats during the highs during the day. So we didn't really see much difference in intake, which is a little bit interesting, but maybe, you know, there was some adaptation going on, and they do get some night cooling as well, so maybe not as big effect on intake. But even regardless of whether we saw an increase in intake or not, we did see pretty significant improvements in performance expressed as in gain, average daily gain, and obviously a resulting improvement in feed efficiency. So that was very encouraging data as well, and that was just here this last summer. So with that, would just like to remind everybody that comfort is available now. It's through Ralco and any of our channel partners, including animal health distributors, which we have worked with several of those that would handle the product. As a reminder, we will send an email following this with a little bit of a white paper technical write-up on this type of a presentation, as well as a link to the webinar. I guess in case you for those that weren't able to watch it or had to drop off early. And in the meantime, if you do have any questions, you can feel free to contact me directly. And I will leave this screen up here just for a little bit, Lori, and we'll open it up for some questions if there's anything from the audience.
Jeff, I did have a question from Dale in the chat. He was asking, what is the cost per head per day?
Yeah, so that's obviously a little bit difficult to answer because it could obviously vary based upon freight and how you're getting the product. But from our, it's going to be somewhere, just from our pricing, it would be somewhere around 5.5 to maybe 6 cents per head per day. It could vary somewhere in there, but we can call it somewhere in that range typically from a retail perspective of about 5.5 to maybe 6 cents per head per day.
Another question coming in, Jeff. We have experienced extreme heat this last week in the West. How soon would you see a response to comfort?
Yeah, so that's a great question, right? So it probably varies a little bit based on the particular mode of action. So for example, these TRP channels, as an example, can be activated very quickly, right? So you could see responses almost immediately, certainly within a day. If the problem has been more ongoing, if we're having changes in gut microbiota or some gut health challenges, that could take several days to maybe several weeks. So it can range, but in most cases, I would expect to see some benefit pretty quick. And with that said, I would also though recommend, because of some of the more extended type issues that could be created through gut health in general, I think it's always recommended, always advisable to feed the product, several weeks or at least several days to several weeks ahead of when you would expect the challenge. But in short, you should see some benefit within days, and then it should improve over time.
Okay, a few more questions here. How many days do I need to feed it? And then right on that, along with that, is Comfort Organic Farm approved?
So, all right, so how many days do you need to feed it is dependent on how many days that you have heat stress, I suppose, right? And so I think it needs to be fed several days, or weeks prior, and then extend throughout the entire heat stress season. So that could obviously vary based on geography. So I would say at least as long as you have the heat stress, the product should be fed. And what was the second question, Lori?
Is it organic?
Organic. So it is not certified organic. Okay, so it doesn't have any OMRI listings or anything like that. But the ingredients would essentially be fairly well accepted. So it would have to be presented to the individual certifying agency that whoever the producer is working with, and they might accept it. But it doesn't come pre-certified with any kind of guarantees like that, any kind of OMRI listing.
A few more questions for you. We have several questions here. Maybe what we should do is take another 3 questions and then have those that still have questions reach out to you. Does that sound okay with you, Jeff?
Yeah, we can take a few. As long as we can go for a little while. That's fine.
Okay. Can this product be pelleted?
Yes, it can.
How sensitive to temperature is Comfort? At over 100 degrees, at what point does your product break down?
Yeah, so it's not going to really break down per se, but it will volatilize, right? So we do have essential oils. Essential oils are inherently volatile, and so we want to do things like we wouldn't want the product setting out. That's why we put it in a foil bag. We want to keep that closed. In the feed, it should be reasonably okay, for the course of a day or, at feeding. So it's something that it is a concern in the sense that we wouldn't want to leave the product exposed, but in the context of just being in the feed or in the pellet, within a day it should be fine. And it's probably going to be a somewhat of a linear drop off, so you're not going to lose it all at one time. But it is important for people to understand that essential oils do have or volatilization points, and every effort should be carried out to try to keep it active. But and when you're not using it, keeping it sealed up. So.
Okay, ready for the next question?
You bet.
How can it be incorporated in pasture mineral programs?
Yeah, so same, right? I mean, it can be mixed in. You just have to scale it in terms of what we would expect the intake of the mineral to be with the level of the product. But yeah, it could be like we'll actually include it in some products as an example. So if you're purchasing a product from Ralco, we can actually include Comfort as an add-on to that program. Or it could be mixed by hand at your individual location. If you had the ability to kind of mix it up by hand, you could do that as well. So yeah, definitely can be included into pasture programs as well.
Okay, thank you. What period should be utilized in dairy cows and beef cattle? Indications of use for best cost benefit.
Yeah, so I'm not sure I understand the context of that question. So, I mean, the only thing I would say is that if I'm reading between the lines here, right? So I think number one, anytime that you have a heat stress, stress in general, right? But particularly heat stress, you're going to create these physiological and metabolic challenges, right? And so anytime that you have that would be a good time, right? Number one. Number two, if we think about it in terms of maybe stage of production, certain animals are going to be more impacted by heat stress than others, right? So for example, a lactating cow is much more susceptible to heat stress than, say, a dry cow, right? Just due to that extra heat that she produces. So anytime you have really high production scenarios, whether that be a feedlot steer gaining 4 pounds a day, or he's weighing, 1,300 pounds, and he's in it, he's going to be much more susceptible than a 500-pound calf that's gaining 2 pounds a day or something, right? So as production level goes up and as temperature goes up, those two kind of combinations are going to really dictate where you're going to get probably the biggest benefit return, return on investment type scenario, for sure.
All right, and another question for you. With other capsicum products I've used in the past, it's been pretty caustic. Is this going to be dangerous for me to handle?
Yeah, that's a good question. Yeah, so capsicum is very irritating. Wouldn't say that it's necessarily unhealthy per se, but it does create irritation without question. And they're all kind of going to be in that category. Now, the product that we use we try to do everything we can to circumvent that. So the product that we use is encapsulated, and that's mainly to give it a little bit better handling characteristics. So also we've changed this formulation a little bit over time to help it be a little bit more stable with the other ingredients so we don't get as much. And so I would say, certainly caution should be exercised. And, just gloves, eyewear, eye protective eyewear, those kind of things should all be included or incorporated. And you'll probably be able to tell once you open the bag, you'll be able to, and everybody's a little bit different in terms of their sensitivity to it. So I would just recommend everybody take certainly good preventative measures and recognize that the capsicum certainly can be an irritant, and proper protection should be used. And I think if all that's done, I don't think there would really be any really danger or anything to be overly concerned about.
Okay. Can this product be used through a micro machine?
Yeah, another good question. So yes, yes it can. Is the short answer. The product we originally developed was not, and then we had some demand for that, so we did change the formulation to be micro machine compatible, and I would also mention that in the process of doing that, though, it did make the product a little bit more stable and less irritating as well, just kind of changing those carriers up a little bit. So we actually made two improvements with one, right? We improved the handling of the product, and then we also made it micro machine compatible as well.
Okay, 2 more questions for you here, Jeff. If the product is added to a feedlot or dairy mineral, how long before it loses its efficacy? Example, should the mineral be fed up within a month?
Yeah, I would say in a feedlot ration it's probably not a big challenge because you're going to hopefully you're going to be feeding multiple times in a day, right? And so it's not, that feed's not going to be sitting around in a bunk for very long. So you shouldn't be any issue. I think in a mineral that maybe is free choice that you put out. So I think in the bag, if it's kept in like in a barn or something like that, and it's going to be pretty well protected, I would say probably a month I would feel pretty comfortable with. But I think in an open feeder, you probably want to be putting mineral out more often than monthly, right? I would say every couple times or at least once a week, because again, you could be getting some direct sunlight. So it is going to be linear, right? You're going to get reductions certainly over time, but I think in those scenarios, in the bag, it should be stable. I wouldn't be too worried about it for a month or two for sure. And it's also temperature dependent, right? And so if it's a cooler environment, then it's going to last a lot longer than if it's super hot, right? So it's hard to answer that question, but it is something I would just encourage good management around to ensure that you're getting all the benefit that you can out of the product.
The last question for you before we wrap up here. Would it be best to have comfort blended into your mineral by your supplier?
Yeah, I mean, I want to say yes, just because I feel like from a commercial perspective, you probably are going to get a better blend of it. But I think that's also really dependent on the individual producer, right? And so some people, have nice, little like cement mixers and do a good job of really mixing it. So I think the ability to blend it on your farm is certainly there, right? I think it can be done very well. I think the likelihood of it always being done well is probably much higher from a manufacturing perspective, for sure.
Okay. Well, thank you everyone for your participation. And as a reminder, as Dr. Jeff Hill had mentioned to you, we will be sending out an email with information shared in the presentation today, along with a link to the recording. Thanks again.
Thanks, everybody.